series on 5G multi-domain slice management. My name is Jeanne Louise Caffrey of RedZinc in Ireland, a partner in the SliceNet project, and I will be your moderator today. We have a very interesting webinar today from SliceNet with our presenter, Dr. Thuy Truong. Thuy is a principal research scientist with Dell Technologies Research, based in the Centre of Excellence in Cork in Ireland. Thuy previously worked as a software engineer in automated tools for utilities. Before joining Dell Technologies, Thuy worked as a postdoctoral researcher in University College Cork, where she did her doctorate on wireless networks, artificial intelligence, and robotic networks. Her current research areas include 5G and infrastructure technologies, end-to-end network slicing, resource and service orchestration, end-to-end security, and their uses for applications and platform architectures. So, as you can see, Thuy is very well placed to lead SliceNet efforts in designing and developing a plug-and-play management framework and an FCAPS framework to address the operation management of slices. These frameworks are applied to the per-slice, per-service functions in SliceNet control instances, serving verticals in energy, healthcare, and smart city areas that SliceNet works with. The purpose of today's webinar is to tell you about the SliceNet technical achievements and innovations in the management plane sphere. We will have time for questions halfway through and at the end of the presentation. I will keep an eye on the chat box so that if anyone wishes to ask a question or make a comment, please feel free to type into the chat box and I can bring this up in the middle or at the end. Please, for now, sit back and enjoy. I will pass you over to Thuy. Take it away, Thuy. I'm afraid we can't hear you. Hey, we're hearing you now. Cool. Ahead, Thuy, and if everybody else could go on. Yes, that's lovely now. Thank you, Thuy. Please go ahead.
Sorry about that. For agenda today, I will give. Yeah, can you hear me?
Yes, we can.
Yes.
I think it's delayed. I'm sorry about that. So for the agenda today, I will give a brief introduction about SliceNet project, and then we will go through the management plan's requirements, challenges, and our technical approach for the design and prototyping, and then our achievements and innovations and the three industrial vertical applications. Finally, we will have the Q&A session with some references. So SliceNet is a 3-year H2020 EU-funded project started in June 2017 and will be finishing by the end of June this year with a 1-month extension. The aim of the project is to provide an end-to-end cognitive network slicing and slice management framework in virtualized multi-domain, multi-tenant 5G networks. The project objectives include a one-stop API with plug-and-play capabilities such as monitoring, auto-scaling, and reconfiguring a VNF in a slice for the verticals, and an end-to-end slice FCAPS management across multiple planes and operator domains for managing faults, configuration, accounting, performance, and security. And then a cognitive agile QE management of slices for service assurance of vertical businesses. And then a cross-domain, cross-plane orchestration to achieve system-level slicing control and slice operation. So the focus today will be the management plan with plug and play and FCAPS management specifically. So the requirements and challenges in the management plan include data collection from multiple and heterogeneous sources. For example, the FCAS monitoring system has to deal with multiple different types of sensors, such as the resource sensors, the traffic sensors, performance sensors, and etc. And information matrix diversity. This is because SliceNet aims to provide a highly flexible system for diverse verticals, where each vertical might require different things, and it does create a diversity in the design of information matrix. And then flexibility for adaptation, extensions, and scaling. For example, the amount and the types of data, the number of rules and operations the system will support. And then the abstraction of underlying network technology specific details. This is to allow separation between business and technology domains and thus enable easier interaction among different business roles. And then the dynamic multi-domain slice management over SliceNet infrastructure. So for the technical approach, I will present our design and prototyping for the plug and play management, and then followed with the FCAS management in a single and multi-domains. So this is SliceNet vision in plug and play approach. So traditionally, we have a monolithic all-in-one framework with a single point of management and orchestration control for multiple slices. And then in SliceNet, we enable per slice, per service functions that are activated, configured, and operated within the management platforms and only when needed. And this is to fulfill the specific requirements for different verticals in their own slices. So this is the different and also innovation in SliceNet. So this slide shows how plug and play management is positioned in the DSP level. You can see that plug and play manager here sitting in the orchestration subplane. It is to manage the life cycle of the plug and play control instances in the one-stop API that serve the verticals, and also to manage the life cycle of the aggregator and the QE optimizer instances in the cognition subplane here. And then in the NSP level, plug and play manager also in the orchestration subplane of the NSP. This is to manage the life cycle of those control plane instances in the QE control, IPC control, and fconfig components. So in summary, the plug and play management is to manage the life cycle of the plug and play control instances that are exposed to the verticals, and it is integrated with the service and slice orchestration at both NSP and DSP level to support per slice management features. And not stopping at that, the plug and plays been evolved towards a more comprehensive slice control and management customization framework, where it goes beyond the customization. Part here the functional components of the framework with the links to the architecture components at the bottom. So firstly, left-hand side here, you can see the monitoring system. It uses the telegraph to collect the data from multiple data sources. And then the data will be pushed into this InfluxDBs, which is a time series database. And then the capacitor will perform data aggregation accordingly. And depending on what have been defined in the application or the scenarios, we will have different aggregation rules defined in the capacitors. And then we have two other main components of the FCAPS, with the FCAPS manager and the rule engine. So the FCAPS manager is responsible for activating all the monitoring artifacts here and also manage the life cycle of those artifacts. And the rule engine is responsible for applying the aggregation rules through capacitor and also for maintaining per slice a set of rule trigger objects that apply the required processing according to the rule definition. So I think I'm kind of
So just
halfway
a
through the
couple of questions
presentation.
there, Thuy, before we move on.
Yeah, so it's a good time for
Yep,
questions.
sorry, I'm talking over you there, Thuy. I'm going to ask a question now from our audience. Could you explain further the whole process on that slide? What is a full control loop in the FCAPS management here?
So a full control loop in FCAS management here, I mean like the monitoring and activation options are associated within the resource of specific network functions, and those network functions are hosted in the slide catalog. And then during the slide instantiation process, and the orchestrator will activate those monitoring and activation options. And then the FCAS manager will instantiate and configure the corresponding monitoring and activation artifacts. And those artifacts will start the monitoring process accordingly. And then during the monitoring process, the artifacts here will collect the data and then push the data into the InfluxDB, where the capacitor will aggregate the data according to the defined aggregation rules, in each application or scenario. And then similarly, we also have a set of rules in the rule engine here, defined for handling the events and alarms related to the subslice for the activation part. So it's kind of a full control loop in the FCAPS.
Very good. Thanks, Thuy. Just a couple of other small questions. Why is it called plug and play management? Are the components swapped in and out?
The plug and play management here, so the concept is kind of for easy deployment and configuration of the instances. Like you can see in my presentation, the control service instances, cognition and management functions. And the instances can be easily activated, configured, and operated when needed. And they can also be destroyed when they complete their life cycles. So the whole process of managing the life cycle of an instance is independent with other instances, and also very seamlessly within the existing system. So it kind of easy to plug in and easy to take out the instance. So that's the concept of plug and play.
Very well explained. And then what is the context of the multi-domain in SliceNet? I think that was back up on slide 4.
And yeah, so this so context of domain and multi-domain in SliceNet here is mean the administrative domain, or you can say operators domain. For example, if you have two domains, it means that there is involvement of two network operators administration. So the concept of domain and multi-domain will be more clear later, when I present some examples of the prototypes.
Very good, Thuy. Thank you very much. There's no more questions for now, so please carry on.
Yeah, thanks, Jenny. That was the plug and play management and a single domain FCAPS management. So in multi-domain FCAPS management, we want to mention that the design of SliceNet system imposes that the service features that the DSP is serving the verticals are exposed by means of three main DSP processing categories. The plug-and-play slice exposure, the QE management, and the cognitive processing. That's the reason, in multi-domain FCAPS management, it does not directly manage the service features towards the verticals, but instead it will support the DSP's plug-and-play, QE optimizer, and cognitive workloads to fulfill the service requests that have been made by the verticals and have been specified in the SLA agreements. For that, the multi-domain FCAPS management address mainly three aspects. Formulation for sensing and activation information to be added in the service blueprint, and activating the sensing and activation artifacts accordingly during the slice instantiation. And then merging the information of subslices from multiple domains in order to have end-to-end slice sensing information that can be fed into those service feature components. And then support the plug-and-play QE and cognitive workloads by providing them the service information that have been collected and aggregated from multiple domains. And for security management, SliceNet focuses on four main aspects. The security orchestration, security events monitoring, detection and response, identity and access management, and mechanisms to secure the system, user data, and network traffic. So the next few slides, I will talk about the prototypes in the FCAPS management. But before that, before we go to details the prototyping, I want to provide a brief introduction of the eHealth use case in SliceNet, because the prototypes are mainly based on this use case. So this slide shows a scenario of an ambulance here connected to the hospital through the network. And there are two applications provided in this use case. Firstly, the blue eye glasses provided by partner. This is for the paramedic to wear and capture the surroundings and then send the video over the network to the hospital where the doctor can see what's happening in the ambulance. And the second one is the telestroke assessment developed by CIT partner. And in this application, we assume to have another camera dedicated to the patient to capture the patient images and then send the images over to the network to the telestroke assessment server here, which is running machine learning algorithm to process the patient images and then send the result back to the ambulance just to see if the patient has been detected with stroke condition or not. So for the following prototypes, we mainly use the telestroke assessment application for data traffic because it has both uplink and downlink data. So this slide shows an end-to-end e-health slice that the DSP provide to the vertical, which is the National Ambulance Service in this case. And then this end-to-end e-health slice can be broken down to a set of network slices provided by two NSPs. So in this picture, this NSP provide the RAN, the MAC, APC, and core slices to the verticals for hosting the application service and connectivity. For this NSP, it provides only the RAN slice and the core slice for connectivity service. So here we have the end-to-end service monitoring that the DSP can offer to the vertical through one-stop API and plug and play. However, for this to happen, the FCAPS monitoring system has collected and aggregated the end-to-end slice sensing information and then store the data in the DSP data store so that this DSP plug and play can fetch the data and visualize it to the vertical to monitor the end-to-end runtime performance of its own slice instance. Then we have the second prototype for the end-to-end performance and configuration management based on vertical feedback. So the idea here is that SliceNet enable application level vertical feedback. So the measurements can be collected from the user equipment, and the data will be sent over through one-stop API and plug and play to this anomaly prediction, which is running a machine learning model to predict future anomalies and events in advance. And then based on the prediction, it might trigger the QE optimizer to perform appropriate activation. For example, it can increase the bandwidth, or in case of predicting the quality of communication will be degraded due to the user mobility here. It can trigger handover event for the UE to move from one RAN to another RAN that is closer to its location for better quality. So here you can see that the ambulance here is moving on this red path here. And it's moving from NSP2's domain to NSP1's domain. And in this case, we are expecting the user measurement to show, the quality of communication is degrading. So the action here is that it will trigger a handover event from this RAN to the new RAN. So the ambulance will now be connecting to this new RAN, in this NSP. Which is closer to its location for better quality. And another prototype is to show the end-to-end fault and configuration management. Here, ambulance moving from this side here, and the service is still running here, but SliceNet detecting that the service running in this NSP is producing unacceptable performance, for example, too much latency or too low throughput. So the action here is that the DSP QE optimizer will send a request to the DSP orchestrator to migrate the service from this side to the edge of the NSP1, and also to redirect the traffic from the ambulance to this new service that is running the service. So in summary, the FCAPS management provides a definition, modeling, and implementation of automation principles that allow the FCAPS management to be activated per slice during the orchestration process, and abstraction techniques that allow the separation between business and technology domains, and a granular and configurable information collection framework for fault performance and security event detection, and then a complete control loop framework that can enforce the FCAS practices, but also support interaction with cognitive processing components. So this is our technical achievements. So we have achieved the design and implementation of the plug-and-play management framework that provides an automated deployment and configuration approach that has been applied to the per slice, per service functions in SliceNet control instances serving the verticals, but also the functions in SliceNet control and cognition subplane. We also achieved the design and implementation of the FCAS framework that aims to address more accurately and consistently the operation management of slices. And we have the exploitation of standardization in 3GPP, SC, and also exploitation of SelfNet in the design of FCAS framework. We have contributed to standardization, especially to the ITUT FG5GML. The proposal has been led by Orange France, and it is to enable vertical feedback and integrating FCAS with the SliceNet cognition subplane. So there are three industrial vertical applications that have been explored in SliceNet project. The smart grid use case led by Altis Labs and FASEC in Portugal, the e-health use case led by Dell EMC, CIT, and RedZinc in Ireland, and the smart city use case led by Orange in Romania. They are to demonstrate three different types of slices that are requested by verticals, and to show how SliceNet can achieve end-to-end network slicing across multiple domains with guaranteed QoS, QE requirements for different verticals. And so all the deliver software components for the plug-and-play manager and the FCAPS are available in SliceNet GitLab in the website here. So this slide is the summary of our innovations. So we have an automation framework of the FCAPS and plug-and-play that allows the operation management to be activated per slice. We have the definition, modeling, and implementation of abstraction techniques that allow separation between business and technology domains. And we followed the technology agnostic approach to support system agility. So this slide has further information on the projects. If you want to know more detail about the project, you can visit our website here. And the deliverables in the projects are published in this website, and SliceNet open source contributions are in this website. So any further questions?
Thank you so much, Thuy. That was a really interesting and informative presentation on multi-domain slice management. The healthcare example was particularly interesting. I wonder, can you tell us who will use plug-and-play management framework and the FCAP frameworks? Are these intended for standards bodies, or are they intended for the network service providers, the NSPs, or are they for the verticals in healthcare and other sectors to use?
Yeah, so SliceNet system, including the plug-and-play and FCAS management, can be offered to both DSP and NSP. If you look into this slide here, for example, here you can see this the whole framework here. The SliceNet system here can be offered to the DSP, and here, the SliceNet stack can be offered to the NSP.
Okay, very good. Are you showing us the diagram there?
Yes.
Okay, it's not showing up on the screen. Ah, there we go.
Yeah. So so you can see we have two different levels. So SliceNet software components here can be offered to the DSP, and then here the stack can be offered to the NSP.
Very good, very good. So just another question from our audience here. Can you explain further the requirements and challenges in information metrics diversity? That was back at slide 5.
Yeah. So information metrics diversity. Yeah, so SliceNet aims to provide a highly flexible system for diverse verticals, which is one of the 5G requirements. And then each vertical can request different things, so it kind of creates a diversity in the design of the information metrics. So the FCAPS has to define and design different information metrics for different applications, different scenarios in different verticals. So that's why we have the information metrics diversity in our requirement and challenges here.
Thank you, Thuy. And another question on slide 13 about FCAPS. How does the FCAPS management support the DSP's plug-and-play, QoE optimizer and cognitive workflows?
Yeah, so the FCAS management will be responsible for sensing and activation information, and also for merging the information of sub-slices from multiple providers in order to have end-to-end slice sensing information. You can say that the FCAPS is performing the service information collection and aggregation from multiple domains, as requested by the DSP's plug-and-play QE optimizer and by the cognition.
Very good. And the slide after that on security, there's a couple of questions. Have you done all of the implementations for security management?
Yeah, that's a very interesting question. To be precise, we have prototypes for security orchestration, where we take the encryption service as a security network function and demonstrate how this security network function can be orchestrated through the Slice instantiation process. This is just for a proof of concept to demonstrate the security orchestration, but obviously you can apply the same principle with other security network functions like the firewall, intruder detection, and etc. We also have prototypes for security events monitoring, detection, and response, where we deployed different traffic monitoring tools. For example, the Dell commercial products like the RSA NetWitness Platform 11.3 that provides a lot of monitoring capabilities to collect data from multiple endpoints, like data center, router, switches, servers, and machines, virtual machines. And we also deploy similar open source tools for similar monitoring capabilities. And then based on the collected data, the system will detect if any anomalies in the network traffic and in the slice. Besides that, we also implemented different security mechanisms in the platform to secure the system, user data, and network traffic. For example, in the health use case, we use in Dell testbed, we implement TOS handshake for end-to-end communication in application level. And for any cross-domain network traffic, to secure the traffic from one domain to another domain. We implemented the IPsec tunneling and also set up firewall rules for those cross-domain network traffic. And in the testbed, we also implemented the NSXT for network isolation. However, for other work like identity and access management, we didn't do prototypes for that one, but we have provided an analysis on the identity and access management in multiple domains contexts.
A huge amount of work done there. And then it's just one last question. What type of feedback are you getting from industry regarding the slicing innovations? So you talked about healthcare there in particular, and I think slicing and prioritization is hugely helpful in first responder type situations. But can you tell us what type of feedback you're getting from industry on slicing innovations?
So from industry, like we have internal, external partners, for example, from Dell side here, we receive a lot of positive feedbacks and a lot of partners, want to collaborate and to deploy thing and find work, in the industry part. So it's very positive there. Yeah.
That is really good. I don't think there are any other questions. So as you can see, SliceNet is following a layered architectural approach to follow the creation of a modular, extensible and scalable framework. The management plane will help progress 5G slicing by progressing frameworks and allowing vertical industries to use these to their benefit in 5G network applications. So we will close the presentation now, and please again remember that we will put the recording up on our SliceNet website. Thank you so much to Thuy for a really interesting and informative webinar. Please remember to join us next Tuesday, the 7th of April, for another webinar in the series. It's on the SliceNet system architecture, and it's by Orange Romania. So thank you for listening, and everybody, I wish you a good day.